Lights on. Lights off. Lights on. Lights off. Lights on. Lights off. Lights on. Who should you subscribe to? Oh, hell yeah.
So the first thing I want to go over is just how this works. I want to do a general overview of this, and then I'll dive into all the details and the code that makes this possible. But the very first thing that happens is your voice has to be recognized, right? Your voice has to be recognized by the computer. Now, on the computer, we have a package called PocketSphinx. PocketSphinx is a special package with a bunch of filters and a limited vocabulary that is all lightweight. It's lightweight enough to be able to run on this much older hardware. And I mean, it's incredible because PocketSphinx does not require an internet connection. Everything that you see is running inside a secure network, you know, on the router, but is also, you know, as far as the speech goes, running on the computer itself on this older hardware. So we're not connected to the internet at all. We're just running on our own private network here, and we're running offline. So I mean, I think that's incredible. But anyway, back to what I was saying, your speech is recognized, and after that, it is put into a conditional statement. So obviously, all of this goes into a Python script. We're going to get to that and the code later. But once this script processes your words, basically, it then executes appropriate commands over to the router. Now, once we get to the router, oh, and by the way, the computer has to be connected to the network of the router. That's a given, you know, that should be obvious, but I just want to state that. And then so it sends over the commands to the router gets them, and it switches on and off a relay, and therefore it switches on and off any appliance that you want. Any device that you want to switch on and off, it can do that via the relay that the router controls. So hopefully, I mean, that's as simple as it gets. Your speech is being recognized, and it's being processed by, you know, code, Python code, and by Bash scripting, and it's being sent over to the router. Once the router gets it, it's as simple as switching on and off a relay, and the relay switches on and off this outlet, and you can switch on and off any appliance that you want. Now, this doesn't apply to just appliances. I mean, of course, you can make a robot that goes left when you say left to the computer, that goes right when you say right to the computer, you know, and so on. I also want to be very clear and state that I'm not going to go into detail on the router. I've done that in a previous video. I'll link the previous video in the description, and that explains basically all the details of creating and running a script, a bash script, on the router, and also flashing OpenWRT, so new firmware on the router. But in this video, I am not going to go over that. I'm going to assume you know how to work with an already configured router, because what I'm going to be focusing on in this video is just like the Python coding and how we send commands over, and just, you know, basically all the details of PocketSphinx. So on the computer that I'm using, it is running Ubuntu, and all of these commands that I have written down here, they correspond to the operating system, the Ubuntu operating system that I'm using. If you're using a different operating system, obviously these commands will differ, but the packages will be the same. So you will need at least Python 3.7, you will need PyAudio for the microphone to work on the computer, you will need pip3, and you should, you know, upgrade the setup tools and wheel for pip. And you will need, obviously, PocketSphinx, the speech recognition package. And last but not least, you will need SSH pass. Now, there's multiple ways of logging into the router shell automatically. but SSH pass is one of the easiest ways of doing that. So I'm not showing you the full code yet because I want to explain some very key points, some very simple problems that needed to be solved before I could implement them in the full code. And so this is what I'm going over now. So one of the problems was executing bash commands in Python. So how do you do that? Because I didn't know when I was playing around with Python scripts. Now, this is one way, this is one quick and dirty way of doing it. You import OS and then use os.system and just put in your bash command here. Now this works, but subprocess is obviously more powerful and should be used more often, but I'm just using it this way. It's quick and dirty and it's functional, so it doesn't pose any problems to me. Now another fundamental problem that I had to get over is how to automatically log in to the shell of the router, and that is using SSH pass. Now with this command here, you can automatically log into the shell of the router. We're not too concerned with logging in automatically. What we really want is to automatically send over commands to the router without any problems from passwords. So in the end, this is how it looks like when you're sending a command over to the router, and you're just using SSH pass, you're using SSH, you're bypassing the password. Well, you're not bypassing it, but you're automatically giving the password when SSH asks for it. And then once you're in the shell, it makes sure to execute the commands that you put into the parentheses. And that's really all there is to it. So this is the Python script, and this is all the code that I'm using in order to make this work. So the first thing that really happens is this is executed. A command gets sent over to the router to execute a script that sets up the GPIO pins. And we only need this to run once. And because we're also running a loop for all these if statements, because these are commands right here, then we need to isolate this command because we only want it to run once. And so that's why we have a global variable up here. So if the global variable is equal to 1, it will execute that command to run the script and set up the GPIO pins, and then it will make the variable a 0. And so what that does is it will make sure that this command never runs again because, since the variable is 0, this if statement is never going to be satisfied. Anyway, after that, we have just commands that are down here, and every time speech is detected, it will go through all these if statements and check, if the word lights and the word on is in the variable word, which is here, then it will execute the command to turn something on and off. So another thing that you should keep in mind is that live speech up here and all the settings that are related to it you can change. This is basically the point in the code where you can input an acoustic model, you can input like a dictionary, you can customize this in a lot of ways to make it better at recognizing speech, because this is part of PocketSphinx. But one of the key things that I want you to notice is that in my case, it's looking for a keyword list. So you have to guide it basically. This is going to be different for you. You have to guide it and make sure it can find a keyword list. So this is my keyword list, and this is how it's set up. You will notice that even if you want to say a sentence or a phrase like "who should you subscribe to," you will need to separate that sentence or phrase into its individual words and list it like I have done here. Now next to each word is 1E-1. Now that setting relates to how sensitive the word will be detected in PocketSphinx. So the setting that I have set up now for every single word is the least sensitive. It is the least sensitive and therefore the most accurate. But because of that, you have to kind of shout at the computer in order for it to recognize that you said something. But that's also a good thing in the sense that when it does recognize that you are saying something, at least it recognizes the correct words. and not something different. Because if you change to the sensitivity, higher, then you could get multiples of the same word. You could also get different words that are not even related to what you're saying. So that's why I set up all the words to the same setting, to the least sensitive setting, because that is the most accurate setting. And I think the highest sensitivity level is 1E-100. It goes up to 100, I think, but I may be wrong about that. All right, I will execute the script now, and it should run. All right, so it set everything up. Now, see, okay, automatically it starts detecting words, and it thinks I said something, and it goes off saying cynical inventing when or it goes lights off, lights on, and I'm just continually talking, and it's just doing its own thing. So in a noisy environment, this might not work too well. That's why I'm saying that this still needs a lot of work, and it needs a lot of filters and acoustic models. But for the point of this video, to give a functional demonstration and a proof of concept for you guys, I think this is a good starting point. Now, of course, if everything is quiet and I say a command, then it will respond. Lights on. Lights off. Who should you subscribe to? See, there we go. I mean, at least it responds pretty well when it knows what you're saying, but it gets really confused when there's no filters, and it just tries to process everything that you're saying, everything that it detects. So yeah, definitely gonna need more filters, acoustic models, probably play with the sample rates. PocketSphinx has its own website, and I mean, they have tutorials on how you can improve PocketSphinx, how you can tune PocketSphinx into recognizing your speech more accurately. So I'll link all of that in the description, and you can play around with this. So I hope you found that interesting, and I hope you use my code to make robots move with your voice. It's going to be interesting to see. If you do something like that, please tweet at me. I'm on Twitter, and I would be happy to see somebody use this as like a launch point, a starting point to like some project that they want to do. Anyway, I'm going to move on to different projects, but this was one of the most interesting things I've done in a while. We've come to the point where we can use old hardware like this in order to control modern hardware. And this is actually fairly secure. I mean, you're on a secure network. Crazy to think that somebody could have thrown this out, and now you're using it to set up like a home automation network or control a robot with your voice. That's kind of far out. That's pretty crazy. So I think that's pretty much it, and I guess we can do this one more time. Lights off. Lights on. It's a little bit slow. Who should you subscribe to? Oh, there we go, it popped up. You heard the computer. Anyway, as always, thank you for watching, and I hope you learned something. I'll see you in the next video.